whatever preference they have. They want to use Jupyter, they want to be using VS Code, they want to be using Vim even, right? Let them do it, right?
There are legitimate things that you want to pay for, right? Like you're going to land your plane. Like you want to take your TensorFlow model, your PyTorch model, and like put it into a device. Like
my personal vision is that, just like in Iron Man, it's probably 10 years old now, Jarvis, this artificial intelligence that was helping engineers develop system. That is definitely what I would envision.
This podcast is sponsored by MathWorks. From the cars and phones we use every day to cutting-edge scientific breakthroughs, engineers use MATLAB and Simulink to build the next generation of AI-driven systems. Learn more at mathworks.com. Cool. Then, ladies and gentlemen, let's kick off the podcast. Yann and Heather, welcome to the show.
Thank you. Thanks so much for having us.
Sure. It's really going to be an exciting podcast. We have a lot to talk about, primarily about Python versus MATLAB, the everlasting battle. Everyone talks about it. A little bit about machine learning, ChatGPT for MATLAB, but also some other topics, and cover some questions at the end from the audience. Let's say the MathWorks or MATLAB fans. But maybe to introduce each, maybe Heather or Yann to the audience. Heather, maybe if you want to give it a go. What are you doing at MathWorks and what's your profession? What's your background?
Sure. Thank you. I'm really happy to be here. A lot of my background involves both MATLAB and Python and, C++ and Java assorted things because I was a physicist. And then during my Ph.D., my dissertation, I did, machine learning for detecting different fluid concentrations. I won't get into it. But so that combination of physics and machine learning, of course, I use C++, MATLAB, Python, and was recruited to MathWorks because of that reason. One of my papers had, cited a MATLAB documentation example. Anyway, that's basically what I do now is help people integrate these things into real systems and, again, kind of dabbling in many languages. My primary language is MATLAB, but I do a bit of everything else because we integrate so often with, different languages in these systems. So again, thank you.
Cool. Nice to have you. Yann?
Thank you, Jousef. I'm very glad to be here with you and Heather for this podcast. I think we've known each other for a couple of years now. So a bit about my story. I joined the MATLAB team about 2.5 years ago, beginning of pandemics, 2020. And before that, I was actually more of an open source champion, I would say, working on a project called Scilab. It's been a while, I think I started almost 10 years ago with this, just right after my studies. And I've known a lot about, this open source ecosystem. I kind of opened myself up to the idea that maybe, I could be working with the big boys, the big guys at MathWorks. And then, they were so nice. So I decided, you know what, actually, let me join the dark side, as they say. And it's actually,
in fact, it's wonderful because, they're clearly we're hiring for someone to help us get into the dark side as well, because, Yann's position is legitimately to integrate with open source. And we even have, developers and teams that specifically work on open source in MATLAB and MathWorks. So it's kind of, I feel like Yann's the perfect example of, hey, there's this guy that invented all this amazing stuff and knows so much about open source. Let's bring him on into MathWorks and help us learn more and help us, do more open source stuff. So yeah, it's great. We work together a lot.
Thank you.
It's pretty cool.
It's great.
It's pretty cool. I like how off camera you're the perfect colleagues, always joking. It's pretty cool to see you talking off camera. Maybe to kick things off, let's maybe jump straight into the nitty gritty. So Python versus MATLAB, the battle that everyone wants to talk about. The first argument that always comes, of course, even for students when I first started using MATLAB is, Python is open source and MATLAB isn't because it costs so much money. What is your argument against that? Maybe Heather, if you want to.
Sure. And so for me, like I mentioned before, like I'm an open source super fan. Like my entire, until I started this job, my entire life was like Linux and, like never paying for anything. And like, even like paying the $5 at the university for MATLAB because I was like teaching it. I was like, oh, that's so annoying. Oh my God. But I guess as I, kind of got into more of the landscape of how people are using these things, it's not just for research. It's not just for, playing around and trying things in the lab. There are legitimate things that you want to pay for, right? Like you're going to land your plane. Like you want to take your TensorFlow model, your PyTorch model, and like put it into a device. Like, oh God, like how much time and money am I worth right now? And how much do I want to actually pay? And so like, I think those are the things that like I really valued. Again, I started MathWorks as like the open source super fan. I was just like, that's me. But it's open enough for me. And it's like, again, most of the time you can get it pretty cheap or free. And for those things that you literally need like expert development for, like you're definitely going to pay for. So anyway, that's my thoughts. Yann, what do you think?
So yeah, I think this conversation is always an interesting one. I often see a bit of a confusion between the open source and free aspect, because that covers many different things. And I'm a big fan of open source, but
like,
there's
what does openness mean?
Exactly. So,
right.
like, open source licenses, there are different types of those. I won't go in detail about it, but I think what it fosters is the collaboration, the community, and that's one of the big reasons why I'm a fan of open source. Now, I'm also really, really aware of the difficulties that comes with it. Coming from my background is just the sustainability, and so we run a business, but I don't think it's not not a secret. And as I was saying, to support automotive, aeronautics, all of those very large industries. And it's just a matter of sustainability. How do we make it so that the access for as many engineers as possible is also compatible with a certain level of quality that we can build into our product. So that's for me kind of like, of course it's kind of a tension, right? But I think we are finding nice ways to make it as accessible as possible. I think in many cases you'd be surprised how cheap MATLAB is. I think you wrote an article about it, Jousef.
Especially, yeah, exactly. So, the deployment aspects. It's kind of, I've gone to conferences before where people are paying like millions and millions of dollars to like set up all these sensors and all these systems. And they're like, oh, production server, like MATLAB, like, oh my gosh, that's going to be so expensive. I'm like, no, like that is like pennies compared to what you're doing. And the fact that there's security, there's things that you are literally willing to pay for, and you can wrap up all the Python, C, Java, R, whatever else you need, it's really valuable in that sense.
I'm thinking you mentioned one interesting point here, that especially knowledge. I think what a lot of people don't talk about is when you buy a license, or let's say you're a corporation or you have maybe a startup and you're buying a license, you're also buying the expertise of MathWorks, which I think is something a lot of people don't talk about. So whatever, system you're working on, you always have an expert who you can contact.
Absolutely. And like, I take it for granted because I work here, right? So I could literally walk down the hall or like ping Yann on Teams or whatever. But literally pretty much anyone else can too. There are amazing, and one of the wonderful things is that that's part of the way that we train people. So, we hire people that have masters, bachelor, PhDs and mechanical engineering, electrical, a lot of the fields that folks are in, including computer science and of course the typical software engineering skills. But, we hire folks and, they sort of learn by answering these kind of questions. And I'm on a lot of development mailing lists. I don't know about you, Yann, I know you're on a few, but I'm on the stats team, for example, on the deep learning team. And, people will ask, like, it's not just like, oh, I'm having trouble with some install or some error. Like, they're literally asking like mathematical questions about, one thing versus the other, and like which thing is more mathematically sound. Similar questions to what we saw. I saw a question on Twitter about precision that we can talk about later, and these are things that people think about a lot. So anyway, go ahead. Sorry, I'm talking so much. Yann, you go ahead.
It's all good. We have all the time. Don't worry, Heather.
I think if I can give some of my perceptive point of view, joining MathWorks fairly recently compared to you, I think I was very, pleasantly surprised by the level of expertise of the engineers working at MathWorks. And sometimes I would think about it as maybe one of the best kept secret of MATLAB is MathWorks. So the people think about the company, they think it's called MATLAB. No, we make the math work. So we are just MathWorks.
True.
and there are people behind the software. That's also why I think it's nice for us to come out and talk to you and share some of the perspective of who are those people from, their background. They're like Heather, she was more in research, and so we have lots of deep knowledge in many fields of engineering, and that is something that I think when discussing open source, it's primarily about technology, but technology is about people. So it is about the people that make this technology. And well, I have to say I've been really happy to meet with all of those people at MathWorks.
Yeah. Would you call it maybe democratization of knowledge / engineering tools? Because at the end of the day, an engineer has to use the tool, right? He's the domain expert. He has to deal with all the data. So it's kind of a bit of a tricky thing if you're in a company and you have to go to the data scientist, ask him, hey, can you build me this thing with Python and build a data analysis, I don't know, Jupyter Notebook. So how do you see that personally in terms of democratization of knowledge and tools?
I think that's such an important question. Thank you for asking, because that's pretty much what Yann and I work on all the time, is exactly this, where, there's such a body of knowledge. I mean, there have been 45 years of mathematics and engineering and scientific experts like contributing to MATLAB, right? Like file exchange existed before GitHub, right? Like there was this notion of sharing knowledge long ago. People use this in courses, they provide their code and everything. And every day it actually gets easier and easier to have these things be able to run easily without having, access to crazy hardware or weird licenses or whatever, like lots of money. People can access this in so many ways. This is something we've been really working on. So I think also, as of 2014, we were integrating with Python. So of course, we've been integrating with C since day one, probably, and Java for a long time. So I think this is also something people kind of think that like MATLAB versus Python. We're like, nah, yeah, whatever. We ship Python. If you download MATLAB, there's Python in there. Like we've been doing that for a long time. So I think there's just an awareness in the community that you use whatever tools are appropriate for the job. And what do you think? You have a lot more experience in open source.
To complement on what you just said about the integration with Python, I think there's a technology aspect to it, but there's also the human aspect to it. So the use case you gave, Jousef, is a really relevant one. A company where you'd have an engineer that is working maybe on like an engine design or like battery state of charge, stuff like that, and then he would go to his colleague, a data scientist that may be in another department, and they need to work together. So that is definitely what I encounter like on a daily basis.
Even the next step, go to the hardware engineer that needs to deploy, right? Like there's so many different people.
There are many different people revolving around those engineered systems, like a car. Cars are now pretty evolved systems.
Lawyers.
Yeah, exactly. And so you need to accommodate and figure out a way to grow the expertise, taking people from where they are, right? So democratizing aspects of bringing us access to knowledge is something that I'm very sensitive to. Maybe that's also my French heritage. Is the democratization is something that resonate very strongly with me. And I think that is in our mission. And if it takes integrating with other languages, then be it, right? Like it's just part of the mission.
Absolutely. And I think that's also one of the things that we really focus on thinking about, like, on like our unit testing frameworks. You could write a script. Like this is the only literal language that you can write a script that you just copy and pasted your like function call, throw it in a script, send it off to somebody, and they can put it in a suite and everything's fine. So it really kind of takes the pressure off of that, expertise. And of course, if you have the expertise, you can do whatever you need and in whatever language you want. So I think it's just such a great community, like awareness now that there is this need for democratization of things and awareness and transparency.
Yeah, I think also a lot of people talk about always MATLAB versus, like if it's, Python, Julia, like what is your strong counter argument against, like, or maybe you give us use cases where you have seen Python and MATLAB working together, solving a specific use case. It would be interesting.
Sure. Do you want?
Who wants to go? Yeah,
I have quite a few. Yann, do you want to talk to anything first?
So a few examples where I've seen collaboration. So there are different ones. So I see different types of persona and kind of situation in which this occurs. So there's like research, there's engineering, and then there are more specific ones dedicated in AI, like trying to develop AI systems, not just the algorithm, but the whole system. And so maybe, Heather, you'd be able to speak more to the last one and
Sure.
to kind of give a summary on each of those. So like the researcher, I think now in certain field of engineering and science, there's a need for kind of a, multilingual way of having people coming from, wherever, whatever preference they have. They want to use Jupyter, they want to be using VS Code, they want to be using Vim even, right? Let them do it, right? It's so that's, I don't think it's focusing on the right thing to just speaking about tools. I think it is about, in this case, accelerating the access to knowledge, the sharing of knowledge. And in research, it's quite important. Then, like you have then engineering where it's, as we just mentioned, democratization and AI. Maybe, Heather, you want to be saying a little more about those particular cases in AI where there's definitely a need for those things to work together.
Exactly, because especially a lot of the MATLAB Simulink users are doing things like, stopping cars and landing planes with AI, right? Like not just like, oh, is it a cat or a dog? Like, did I get the wrong movie recommendation? It's like, so what, but in this case, so what is like really important. Like the braking system didn't kick in because your AI system was wrong, so that's again, a lot of MATLAB and Simulink users are faced with this and also have those regulatory requirements. Like when you're literally putting this into production, like lawyers are involved and regulatory bodies are involved, and they don't even like F equals MA. I feel like they're not going to like all these crazy layers that they don't understand. So, we're really, thinking the whole community, in fact, is just thinking about how to now bring this AI world, into those sort of skeptical, scientists, engineers that know enough that they can, figure this out and they can educate others and make sure those regulatory bodies, the lawyers, the users even know what's going on. It's really important to keep everybody informed. And so that's a lot of the sort of work that we're doing. And again, regardless of what language you're using at any of those different phases in the process, the important thing is that we're trying to communicate it and, bring it to anyone. So we see a lot of people using MATLAB, like even I joked with Yann earlier this week about folks that are using MATLAB production server to run their Python tests. Because it's way easier to just hit a couple of buttons for a production server, just add all their Python code, and they just like done, hand it over to IT.
That's definitely a use case that I didn't cover when I was mentioning the different ones that we encounter. This relationship with IT, this deployment is not trivial, right? Like it takes a significant amount of knowledge to know how to handle Docker containers, stuff like that. So it's like you cannot expect that from a domain expert. You shouldn't expect that from a domain expert. They should focus on their engineering stuff.
And that's another thing that I wanted to just quickly point out is that, whenever we're talking about hardware, I know, I guess if a lot of your listeners are probably more like a lot of hardware folks might be listening in. And, as you know, there's a big difference between having all the resources available to you on like Amazon cloud forever, all the GPUs, like, let me run this model in like 20 seconds, except that like, you have hardware, it has like a couple megs of memory and you're bringing in this amount of data at a time and things are just different. So that's one of the things that I really value MATLAB for, again, using both of them for AI. I can take a Python model, fool around with it, do some parameter sweeps and things like that, bring it into MATLAB and then prepare it for that hardware case where I'm, who knows what precision I'm going to need. I can use the tools that we have available to, get that code in shape and get that model in shape for the next phase.
Mm-hmm. I think that makes sense. Talking about AI, I feel, I don't want to say me, but over the last years when I've checked Reddit or other communities, sometimes, especially students, they think of MATLAB for AI as kind of like a joke because they don't see the capabilities in it. How do you personally see that? Because Python, makes sense, PyTorch, TensorFlow, and all these other frameworks that exist. How does an engineer, for example, take MATLAB and use it for his AI purposes, let's say?
Yeah.
How does the workflow look like?
I have many opinions. Yann, do you want to go first? Because I'll talk forever.
So I think a bit of a definition is always interesting to kind of precise what we speak about when saying AI. There have been many waves of AI, and it depends what you want to talk about. If you want to speak about the latest and greatest and shiniest, now it's actually not Python anymore. It's ChatGPT. So it's moving so fast. But you have also so many other techniques. Like you used to have computer vision, and we have a very good support of computer vision. Honestly, that's really good. You had machine learning, and our approach to machine learning, just like regression, classification, basic stuff, is really good. It's like really competitive to what even scikit-learn provide in Python.
Literal statisticians work on it.
Yeah, honestly, if I had to choose it for, I took courses on scikit-learn and I quite like it. It's a beautiful design and all. It's French. it's coming from INRIA. That's also kind of my heritage.
And
but I really like the apps that we provide because I'm not going to remember everything about every detail of a classification, regression tree, whatever. I cannot focus on that. So I like the apps that we have, the classification learners, regression learner, just click, poof, trains a bunch of models. I don't need to know. And then
there's just enough information for you to know, right? So one of the things I kind of value, again, we have those mathematicians and statisticians that think about this all the time and argue all the time. Trust me, I could talk for hours about crazy arguments. But we have these things where it's it grays out the models that are not appropriate for your data. If you have categoricals and the model doesn't work with that, well, that's just not even an option. So it kind of, I feel like it really helps guide through. And, people talk about black box or opaque box, models. That is not okay for MATLAB people, right? They they're scientists, they're engineers, they're mathematicians, they're IT people. They need to know something, right? So we kind of give them enough information as they're going along, visualizations, ways to tweak the model and understand it, that focus on interpretability, explainability, because again, it's not just oh yeah, sorry, you got the wrong movie. It's sorry, you crashed the plane.
Oops. And that would have been my next question. Very, very, very interesting. So explainability and interpretability. So what options do engineers, for example, have? Because, well, as we all know, all models are wrong, but some are useful. So how does an engineer, because one thing maybe from mind, what I really like about MATLAB or the graphical user interface is its simplicity. So sometimes I have tools, and remember from my studies, you have like millions of buttons, and then you're like, okay, what am I even clicking in the first place? So how does MATLAB approach this, especially from an implementation perspective? The simplicity, but also tackling very challenging, intractable physical problems at the same time.
Yeah, and that's a great question. And I'll just kind of speak to it first with that. Yann mentioned the apps, like that's exactly the focus where, we assume people have some general knowledge about math, general knowledge about their problem, and give as many visualizations, as much information as you possibly can. Here's the data split. Here's what's happening. You get to choose, or at least it tells you if you use the defaults, what the, k-fold loss, those kind of parameters. It gives you all of this information. And then, again, you can kind of dig a little bit deeper as you go. So as opposed to sort of the world where, of course I've been in all of these worlds, but, I just search around and find the best PyTorch model for blah, blah, blah. I copy paste the layers and if I would bring that into MATLAB, I can now visualize it, move around the layers interactively, like look at a graph that, shows me, a graph, like a matrix algebra graph, like shows me all the potential challenges that I might have, so even though I fluently go back and forth with AI problems and, again, I'll just use whatever I'm reading at the time or whatever makes sense. And, I still will bring it into MATLAB for that last kind of phase of tweaking those parameters, visualizing, explaining, again, because it just is quite valuable in the tool and people are working on it all the time.
Yeah, interesting.
So I'm not as experienced with explainability as Heather, but so what I would say about it is, so first is I think you mentioned this famous say from George Box is all models are wrong, some are useful. I've heard a text completion of it that says under certain limits and conditions. And I think that's also what is important in engineering is understanding, and in science as well, the limits and conditions of a model. And that is something that you need to be very rigorous about. There's like very important, lots of importance in the data engineering, not just the model part of it, because like we all like to train model, that's fun and all. But actually, when you go to serious work, to do serious work with modeling and prediction, you realize that you may end up spending more than 80% of your time on the data piece of it, not so much the training. And in order to put rigor into it, to make sure that you have qualitative results and that you can understand them, I would say my suggestion is test as much as you can. And as I mentioned it, we have pretty good tools around the validation and verification of systems like AI systems now, but used to be like code-based system, model-based system. So it is certainly, I think, just what I would say about it.
Yeah. And definitely, like, you can call PyTest, you can call other, frameworks from there, so we see a lot of people kind of pulling it all together, and we mentioned before about production, you can take that Java code, the Python code, the whatever you want, C, CUDA, and, put it into production server, like hit a couple buttons and implement it pretty easily. There's an example already for you. So I think it's awesome because it kind of brings together all those worlds of engineering. There's so many different aspects of it. So it's kind of perfect to bring all the different languages and problems together.
And I think a colleague of ours, Lucas, just released a new support package for validation and verification of AI systems. So I think if you want to, share the link, that'd be definitely something good for the audience to look at.
And it's such an important area, right? Because, there's verification, validation, those certification bodies that we were talking about. And this is such a fast moving world that, the F equals MA skeptics are, we need to get them on board, right? So there's constant work being done in the community. And of course, at MathWorks, with our experts in testing and figuring out, what actually needs to go into AI testing, and especially for devices or for, your application.
This podcast is kindly sponsored by MathWorks, the leader in mathematical computing software. Engineers and scientists around the world use MATLAB and Simulink to build the next generation of AI-driven systems. From the cars and phones we use every day, to breakthroughs in medical devices, digital health, green technology, and space exploration. MathWorks is helping to accelerate the pace of AI discovery and innovation. Learn more at mathworks.com. Yeah, that makes sense. I would have a question about performance, but before that, you mentioned expertise. Now, Yann mentioned ChatGPT. I was wondering, because we talked about buying basically all this expertise. You have all this knowledge from the MathWorks people who are super smart. So once ChatGPT becomes more smart, let's say we think about ChatGPT 4, 5, 6, and so on. Do you think that people will still use Python and stay away from MATLAB because they have all this knowledge packed into this huge tool? So you can just, hey, build me this app for deployment, for everything we mentioned before. Do you think there will be a major blocker, or like for people saying, no, I'm not going to go with MATLAB because I have ChatGPT plus Python plus Julia, whatever. So why would I spend a couple of $1,000s on MATLAB?
So what tells you that you won't have ChatGPT with MATLAB first?
It was like, Yann and I just spent 2 hours in a meeting earlier about ChatGPT and MATLAB. So it's something that we're always thinking about how to enhance this. And like, for me, at least, I mean, maybe this is a personal opinion, not necessarily a company opinion, but, the math knowledge is not there, right? And the big language models, the large language models, it's just not. So that's one of the futures that I see, where we could really provide a lot of resources where we have so much information about math and, what is actually okay. It's just like internet math is not, we need to help train this model, so I've been doing some experiments with give me some MATLAB code, pretending I pulled an all-nighter and I don't know anything, or I don't know, things like that, like trying to see what the quality of the code is. So there's a lot of us doing research on what's being provided now, how we can help support this, how we can adapt and have sort of our Mat GPT. We'll give a link to that too, because we're getting there. But I think there's a lot we can do with our mathematical and coding knowledge. And last thing I'll say, because Yann is relatively new, there's, 45 years or so of MATLAB code out there. That's a lot, even though we'll stop ChatGPT at, this time, professors still reference links from the 80s or whatever, so I think that's one of the big challenges for even Python code, even for me, I'm like, I don't know the best way to do this. So if you're getting ChatGPT, it's like using the best, most awesome, newest toolboxes or packages or something, because otherwise there's just a sea of knowledge out there, and some of it is good and some of it isn't. So we're working on it. Yann, sorry. Yeah, you have been experimenting a lot with this.
Yeah, I quite like it, I have to admit. And I like, Jousef, that you're, projecting kind of a longer term view in this conversation, because all of what we'll be saying now is going to be obsolete in 1 week, very surely.
Of course.
So it's important to kind of look a little ahead and think about, what is it that we should be thinking about long term. And for me, again, I think, as I said, is for now, it's not a company position, but my personal vision is that, just like in Iron Man, it's probably 10 years old now, Jarvis, this artificial intelligence that was helping engineers develop system, that is definitely what I would envision for us, because it's not just code, it's engineering.
Super smart Clippy. Super smart Clippy. Clippy. I have Clippy.
Clippy was annoying.
Oh, super annoying. That's why we're going to train it better. And you have to ask for it. It's not just going to show up whenever you want.
That's good.
And definitely, I think the same way, right now we hear a lot about ChatGPT plus Wolfram, for instance, the capability of adding two large language models that are essentially just a clever statistical machine that just predicts the next word from a just probabilistic point of view, then it doesn't have any, first order vision of the world. And again, like coming from, a Cartesian background, it's important for me to say, all of the F equal ma, laws of nature that we know we've learned for centuries, right? So let's just not forget about it. It can complement so nicely this beautiful intelligence, whether it's an AGI, general intelligence or not. It could be very nicely complemented with tools such as MATLAB. So I'm quite hopeful. I won't commit to anything right here, but I think we have lots of interesting things to see.
Yeah, we're excited. I think, having sort of the knowledge of all the textbooks and all the things that people have used in research and stuff like that would be really amazing. And again, we're like thinking about like Bio GPT, Chem GPT, Mat GPT is the more general one that Toshi just released. But yeah, I think that's really important to think of how we can all contribute to this world.
That's pretty cool. Yeah, by the way, shout out to Toshi at this point, because he was building the MatGPT thing.
He's amazing. I don't know how he does it.
Pretty cool guy. We'll talk about performance very quickly. Obviously, there's also this counter argument of like MATLAB is not performant. I was remembering when I was implementing like a stability analysis of plane Poisson flow back in university. It was like 2D, which for me was okay. You could still implement it. It was performant. But then when you go to 3D, maybe computational fluid dynamics, finite element analysis and whatnot, there's always this argument, well, MATLAB has a GUI, it's super slow, but MATLAB, I don't know since when, has GPU support, if I'm not mistaken. So how do you go against that argument, saying, hey, MATLAB has a GUI, it's super slow?
That's true.
That's good.
Right,
I love the honesty.
All GUIs are slow, right? Like, you could do anything from Vim. That's why I like Vim. Yann mentioned it before because he's making fun of me. But that's my IDE of choice because there's no overhead ever. But I think that actually kind of speaks to the application, right? So like whenever I am fiddling around with data and I'm clicking on stuff and I'm like, wow, like I love coding. I am dyslexic. I love code. I love how it's indented. I love to speak math, whatever, so even ChatGPT, I'm like, whatever, I want to code, so for me, I love that kind of stuff. And I still, and I know C++, Java, whatever, I still love MATLAB because I can click on it kind of like Excel, but I don't actually have to open Excel, and try 8 million different plots, copy, paste, drag the code into my function or my class or package or whatever. Like it kind of goes really well with your exploration. And so if part of that exploration is kind of with Python, that's fine too. But anyway, the part that I value, I guess, anyway, that's the IDE part, that it doesn't matter how long it takes. It doesn't take that long. You click on it and it's like, whatever. And if you have, code that is running long or whatever, a lot of people don't realize you could literally say use parallel or like use GPU true. And it actually does it like on its own too. So, I was kind of spoiled. Like I was in the lab and using like crappy old computers or whatever. Now I have a GPU and it's like, everything is like super fast and slick, So I think there's a kind of misconception that, you're clicking around with things, I guess everything's going to be slow if you're like, I don't know.
I like the honesty though. It's like trying to get something else out of you. It's like,
true.
No, well, it's slow.
It's slow. So. I mean, like it's slow. It's doing all kinds of awesome stuff, right?
I mean, I guess we need to kind of differentiate in this conversation the MATLAB application from the MATLAB language, right? The GUI, the graphical user interface is one thing. And I mean, okay, it's an application. But then the language itself, then when we step into the language conversation, there's always one that is interesting about performance. I would break it down into several definitions and how to address things. So like, for instance, just the basics, matrix laboratory is who we are. What we do is matrices. And so if you think in a vector way, then you could have things that are vectorized that go much faster than just iterating on loops. And people like loop. I get it. I loop myself. I loop a lot.
Sure,
right?
you can, I guess.
But that is like the first big difference for me between MATLAB and Python, like a generic purpose programming language like Python, and I love it for this what it is. But when it comes to numerics, then I mean, like, we're pretty good at it, right? We contribute to LAPAC, that is a foundation of all, numerics for everyone, everywhere.
Like, pretty good at it. I mean, like, Cleve kind of invented all of it. He's still on the mailing list.
I think on this front, it's, we're doing well. So on the optimization of programming as you would just write it, if you want to write loops, then we have all of the just-in-time compiling that is really performant, honestly. And so in this case, again, like, you could compare it to Numba or other ways of doing just-in-time compiler in Python. Personally, it's more a matter of how you express yourself. I tend to just, like, as I said, like to express myself maybe with MATLAB when it comes to having performance at this level. And then as I said, is then what matters most when you speak about performance is when you are in production. So when you're in production, you have a code that is very performant. You want to parallelize, then boom, we have a parallel server. We even have the parallel toolbox that can do that with leveraging just the different cores of your machine. As the GPU, if you have a GPU, just like, there are lots of options. So the performance thing, I'm not going to take it.
Streaming and like sort of the caching, a lot of that is really pretty easy to do in MATLAB. Like, there's just, click.
And at the end of the day, if you want to generate C code and write C code, because C code is
the fastest one.
Compile code will never be like it. You can never beat compiled code. So with any interpreted language, whether it's MATLAB, Python, Java, whatever, well, C code is just more performance. It's just the way it is.
But then people would say I could also use C Python.
Exactly. But also I think that's where I like to differentiate, where it's like, I'm going to a device, right? And like, granted, a lot of I advise other people, but I'm talking about like a, silly like NVIDIA thing, just trying things out and playing around and making sure it works. But that's where it's like, you try to do this with CPython with certain models. It's like, has anyone done this before? You go through, the forums and you look at the dates and you're like, oh my gosh, okay, this is like outdated. Like, what version do I even need? Oh my gosh. So I guess that's where I kind of find the difference where, when that actually matters, there's GPU coder, for example. Like, I tried this a couple of times for, a backyard trail camera to see whether they were bunnies or deer. Okay. They're deer. All right. It's very important. Anyway, so I have it on a Raspberry Pi. But so if I were to have done that entire thing in Python or even like Circuit Python or anything like that, it just, I was able to test and, try the algorithm and do all the data analysis stuff that Yann mentioned, relabel the images, do all that kind of stuff in MATLAB. If I wanted to bring in a Python model, I could, and then I just like bust it out to C. And then it gives me an example for that, Yeah. So whereas like if I were to do that in Circuit Python or C,
if I were to summarize what Eza just said is, I think we mistake ourselves sometimes when we speak about performance, when in fact, the time that is spent on your GPU or CPU and your hardware is not as important as the engineering time. That honestly, for many of those conversations, I think we are having the wrong conversation. I think we should optimize for the human, not for the machine, because the machines are becoming pretty good at what they do, right? So now we need to optimize for human productivity, engineering productivity in particular. And performance, I mean, like, we're doing pretty well, honestly.
Yeah, we got whole teams dedicated.
Oh, yeah.
That's pretty cool. Regarding AI, I think even MATLAB is not that slow when it comes to developing AI toolboxes. I think there was even the first perceptron or something like that, a toolbox in 1992.
92, yeah, exactly.
92, it was pretty sick, actually. I was looking it up. I was like, 92? That's pretty old.
Yeah,
that's pretty cool.
I insulted most of our bosses one time. I was like, "Does anyone have a screenshot from way back when, like way back in like the '90s, like when it was invented or whatever?" I didn't mean to be insulting. It was a compliment. But we were doing the Coursera course, and was talking about like one of the big questions. It was like, when was the first neural network, or when was the first machine learning algorithm? And it's like, depending on which mathematician, like ridiculously renowned mathematician you ask in-house, it's like 1980, blah, blah, blah. We had binary trees. Like that was the first classification tree. Or like there's, polynomial fitting from day one, so these things have been around a very, very long time. I think now, we're just seeing so many more people enabled with Python, with R, with the rest of the community, including MATLAB, but it's always funny. People are like, "Oh, wow, you do deep learning?" I'm like, sort of was like invented like here.
We can even listen to what's his name, Geoffrey Hinton at the last NeurIPS. He said, "Guess what I use? MATLAB."
Yeah.
That's
Yeah.
really cool. Nice. You're not also doing only doing deep learning, but also reinforcement learning. A lot of people also don't know that, so it's pretty interesting what you guys are doing.
Yeah, especially since reinforcement learning often deals with controls and, making those decisions and doing things. Like it's just such a natural thing for MATLAB users and developers to think about. So it's actually really excellent. I was at NeurIPS recently in November, and our demo was this, stick that was reinforcement learning itself, and it was a huge hit. I was like, wow, really? We were right beside TikTok. Like people are like dancing with like filters. But everyone was all about the reinforcement learning demo, because I think, again, it's such a natural application for MATLAB users. And, it's really exciting for other folks in the AI space to learn about. There's even a 2-hour free course that you can do right now for reinforcement learning.
No. And also we will put in the description the links to the Coursera course, because I think they're really, really good. Data analysis.
Mm-hmm. Yeah.
Is that what it's about? Data. Pretty cool.
Yeah.
So I'm going to put that all in the description to check that out. Let's say if I'm a business owner and I don't know if I want to go the MATLAB path, maybe join the dark side, or go the Python route. Do you have kind of a decision tree kind of way that helps people basically decide, should I go one way or another? So what is important for me, let's say as a business owner, or I want to solve a specific complex physical problem? What do you recommend people to choose?
Yann, do you want to speak to that first?
So like a tick box where you say, okay, check, okay.
I mean, if you own a business that develops engineered systems, then I would definitely advise you to look at our startups offering, because they're really affordable, and honestly, like that is going to give you a head start into the competition. So, and this is all of what you need to think about, right? Like it's your time is more valuable than just maybe. I think it's $1,500, honestly.
It's like 100 to 120
really,
euros
like
a month.
How fast can you get to prototypes, to actual demonstrator, to demonstrate market fit with your product? This is what you should be focusing on. And honestly, well, I think that you could be considering MATLAB for that.
Yeah. And again, kind of speaking to what we talked about earlier, if there's some certain model in, the community that you're really interested in or whatever, like you can also bring that into, so I think, like Yann said, when you wouldn't need to kind of get that serious application going from, 0 to production in a couple of weeks, or, and then you can iterate on it and bring in a whole bunch of different types of people with all different types of language. That's really where I would reach to MATLAB. Again, just because of the focus on that whole experience, realizing that a lot of users are doing this very thing, working on large systems and needing to go from one phase to the next.
Yeah. And I mean, I'm not saying don't use Python. I love Python myself. So
yeah, it's amazing.
It is, yeah. Especially like, if you want to bring in some AI stuff in it, well, then why not? I mean,
yeah. And there's a whole bunch of people that do that, right? Like there's so many different ways that you could do that. Like you could call the Python interpreter. You could just do, PyTorch. What is it? PyTorch model.
Yeah, you can import Python models. You can import TensorFlow.
Import TensorFlow, import blah, blah, blah.
Yeah.
And people will do that for this very reason, where it's much easier to like take a model from Python than, take that next step onto the device with MATLAB. You just click a couple buttons, get the test code, and you're good. So yeah, we see a lot of different, applications of AI back and forth.
Yeah. Now that we talked about AI, I think it's a very fast-moving technology. Now, if we look into the future of MathWorks, what do you guys plan? Of course, not giving away all the secrets, but like, what is planned for the company MathWorks in the future? Maybe Yann, if you want to talk about the vision or mission statement.
We'll be fired, I think, if we say anything.
That's not the purpose of the podcast.
No. But honestly, I think from my perspective, at least the stuff that I've been working on, it's really trying to bring access to MATLAB to people. There's a lot of focus that requires a lot of, business acumen and lots of people in conversations, but, really bringing different levels of access to MATLAB, for literally anyone. So that's a big focus, and, we'll see more of that. It's just, again, that focus on open source, focus on really enabling the community and engaging the community. So at least, Yann and I both work very closely with the open source team at MathWorks. We're really trying to get as much as possible out there on GitHub and MATLAB Central, and sharing information like that. And then again, from my perspective, a lot of the sort of explainability aspects where you're trying to understand your model, you're trying to understand your data, and just getting information, really focusing on bringing this information to people.
So, yeah, I would also say that there are a few mega trends that we are tracking for a few years now. And so this is just like the refinement of our long-term strategy, which is essentially, so AI is one very big trend. Cloud is another one where we need to also continue evolving our technology in the direction of being more cloud native, which is very long-term investment we are making. And we see the need for this more and more, especially now with systems such as those AI assistants that would bring you inside of your environment, if in your engineering environment, the relevant information at the right time. It's all about bringing this to the user, this experience to the engineers, to the scientists where they are. So we want to keep focusing on them. That is certainly, our strategy is to keep on focusing on the engineers, on the scientists, and bringing them the right element. Now, I think some of it will have to do with generative AI, with large language models. They will necessarily bring large, transformation into our technologies, as we will need to have more distributed systems. The MATLAB front end will always be the front door to the engineers. I still strongly believe that, you'll still always use desktop software. That is not going away. But then you have new things like code spaces where you want to be flexibly using pre-configured environments in the cloud to get started, to test your thing, to do virtual testing, right? Do all sorts of things that you may want to be doing as part of your engineering lifecycle. And all of it will be enhanced by AI. So, I'm quite looking forward to what it would be concretely.
And I think it's also nice to see how MathWorks has evolved to, some of the things that Yann was talking about, these CI integrations, all these things that pop up like every day, literally. These are the things that we support on GitHub so that we can support these, when they change, and we can be a little bit more adaptive, as opposed to the sort of 6-month cycle that you put in your hardware. Right. So I think that's also something that we'll see more of, really kind of enhancing that community contributions and sort of real time, learning and adapting. So yeah, it's exciting world.
That's also, I think that's certainly kind of a call to action if we were to conclude on this to the community, to the audiences saying, you're part of this transformation. So tell us what it is that you think is going to be fueling your next engineering application, your next scientific application, because MathWorks is by nature, I think we are kind of a control system in a sense that we take feedback from the environment and we just process it and we just embed it into, that's our DNA. So we kind of need this connection with the ecosystem in order to build this infrastructure for engineers.
Exactly.
That's super cool. We're almost approaching an hour of the recording. So before we go to the questions from Twitter, I would have one question. Yann mentioned AGI. So assuming AGI system will be live by next week, for example, what's the first question you ask an AGI system? So Heather, you go first.
Oh my. I don't know. I mean, I guess, no, Yann, you go first.
I know that my personal
I've already done a whole bunch, but they're embarrassing.
I had kind of a philosophical one. It was, are we in the matrix? Are we in a simulation? That's pretty deep. Sorry. Like that was my personal first question that I asked.
That's a good one.
That is a good one. The first question I asked was to summarize a book chapter because I'm leading a book club at work and I didn't read it. So I needed to summarize a chapter for the book so I could pretend. Okay. So I've been using it for very practical purposes, although Yann's is more, existential, philosophical. Mine was quite useful.
I mean, I definitely wanted some help to write a book on MATLAB with Python. It's a shame that I had to write so many things myself before GPT, right? It's like somehow we will delineate the time in history before GPT.
Yeah. Well, again, you're still using 45 years of perhaps misinformed information if you're using ChatGPT. So, maybe it's okay that you're involved, Yann.
Do you want to quickly talk about your book, Yann? When is it coming out? No pressure, by the way.
I think you have some stuff on GitHub already. That's MATLAB with Python. So I just tried to compile all of the learnings that, I came across. The first chapter is just really pragmatic end-to-end project that Heather and I have been doing for ages now with a simple weather example. I quite love it still. Like honestly, it's just really good getting started. So yeah,
everyone knows about weather and air quality and climate and things like that. Other examples we have is imagine you're trying to make your battery more efficient but weather is easy. It's quite nice.
Awesome. So we're going to cover a couple of questions and then we'll call it basically at the end of the podcast. Question number 1. Are there any performance issues running Python scripts in the background while running the main MATLAB script? That's question number 1. Who wants to take
Interesting. That? So it gets directly into the nitty-gritty of performance of co-execution. So we've made it pretty transparent, honestly. We have different modes of execution. Not going to go into too many details on how it works, same process by default, but then you can go into 2 processes and then you may have some overhead in passing data around. But generally, if you can run in the same process, it's pretty good. It's working pretty well.
Mm-hmm. Yeah, I'll say too that that's something, since it's been out since 2014, the teams very closely, compare release to release. So if there's something that is not performant, let us know for sure. But it should be very, very minimal overhead, especially if you already opened MATLAB. You already got the big one, all the IDE goodness that you need. So it's super quick. And the second you call or you import something, it's there. A lot of people kind of get confused on whether they're importing stuff over and over again or, how some of this stuff works in the background. But, it's quite good. And I'll say maybe this leads into another question that probably the most overhead people run into is the data type conversions and those decision-making things, like that.
Yeah, I think there was one question regarding data type conversion or precision, if I'm not mistaken, on Twitter. You want to take that one?
Yeah, Yann, do you want to start on just general type conversion, and then I can kind of dig in? There was very specific mathematical precedence, integer things.
So more generically, I think we've made good progress over the couple of releases from 2020 to until now 2023 to make it really seamless for you to pass the generic data types that you have in Python to MATLAB, and also the other way around. So like, for instance, you would have a list or a dictionary in Python. You can just pass them over to MATLAB. That's actually fairly easy now. Even with NumPy arrays, passing NumPy arrays to MATLAB arrays, it's almost seamless. And I think in terms of even performance and everything, I think it backs to the same memory, so it's very performant. As for precision, like double, single digits, floating point, I would leave it to Ezra.
Yeah. I was gonna say that's one of the things that people run into, because like the default, like if you just type 42 in Python, like that's an integer, but in MATLAB it's a double, and mostly because of like how sensitive MATLAB users are to precision of things, right? So we're not just gonna willy-nilly like decide what integer you want, so that's one of the things that people will wonder about, like, well, hey, this is like a Python integer, what should I do in MATLAB? And it's like, well, there's uint 8 or 16 or signed integers and unsigned integers. Like we're not just going to willy-nilly do that because we're so sensitive to hardware, right? So I think that's one of the things that to keep in mind. Those default underlying data types will convert pretty automatically, like a char, right? Like it's like C to C. Some of those like sort of quick, easy scalars, we'll be able to convert those automatically. But then when it comes down to like the more heterogeneous structures, a lot of that is kind of left to the user because it's unclear how you exactly want to represent that in MATLAB or Python. So that's just one kind of general thing, kind of just to add on to what Yann said. And then, again, just because of the super precise way that we deal with precision, I'll just say that I emailed the math team earlier to help address the Twitter question where, integer, their integer is being concatenated and it's unsure what value or what data type they're going to have. Generally, MATLAB will set all elements of the resulting data to the data type of the leftmost element. So it's usually the least precision and left. So if that helps. And I have some links that we'll share. I'll share Jousef after this that will help, clarify some of this.
Perfect. I think that was very in-depth. Cool. Native app for Apple Silicon, support of the GPU course on Apple Silicon, ? Simulink mobile, ? I would love to use it on my iPad with a pencil. So.
Okay.
Yeah, let's do it.
Sure.
Let's do it. So I think Hans actually answered this or responded on Twitter. There's a beta for Apple support. So again, we'll add this to the links that we provide.
Yeah.
So yeah, there's a lot of great work going on with Apple Silicon and MATLAB, as well. Well, it's possible to use Simulink mobile. There's like Simulink Online now. Mm-hmm. So I'm not sure about the future of Simulink mobile, like sort of like MATLAB mobile, where you're using the sensors and things like that from your phone. But we can pass that feedback along.
I'm interested. I'm curious to know what type of application they would have in mind to use Simulink on an iPad or mobile. Mobile would be pretty small. I don't know. Like it. And
maybe it's like
sure
right. And like at this point, if you're trying to just run a simulation, you could actually do that in MATLAB mobile, just like by calling sim of your thing, So it would be really interesting to learn, if there's other stuff you want to do.
And it's backed by MATLAB Online. So like, I think in those types of scenario, if you have like decent model, then probably the processing, the simulation would be done on MATLAB Online.
Mm-hmm. Cool. All right, 2 last questions. Number 1 is bring back options of the OG log of scripts. I missed the background color change in the section you're working with. The autocomplete is so intrusive, I've worn out the escape key. I think regarding looks, I think you released, was it dark mode that you've recently?
It's a beta.
It's a beta, yeah.
Okay.
Secret. Shh. Just kidding. But yeah, because like there's constant work on this. There should be some options in the like preferences to sort of go back to the defaults. I just opened up MATLAB just so I could look at it. But I believe there should be some like preference to not use like the code suggestions, to, you know, use sort of the old school, the OG colors, if you will. Yeah, so I'll try to send some links along for that too.
Perfect. So if anyone listens or watches the podcast, we have a ton of links to go through. Sorry for that, or like you're welcome from a perspective you're seeing it from. But yeah, cool.
Sorry, and
last
thank
question.
You're welcome.
All good. Last question is, this came in right before the podcast. Maybe you know what the guy means. Is MATLAB the reason AI is lagging behind? And with Python, would it have been a different story? So I'm not sure why MATLAB is maybe the reason AI is lagging behind.
No, so first I don't think AI is lagging behind. Honestly, seeing the pace of innovation right now, it's pretty intense. And honestly, like again, I mentioned Geoffrey Hinton, one of the inventor of all of this. We have to be thankful for all of the founding fathers, so to say. He's using MATLAB in order to prototype his algorithm. So honestly, I don't think it's well funded. I think it's misplaced anger and haters, which, you know, everyone has. That's fine. And I think that what happens in AI is that, you know, again, like we had so many ages of AI. I think there's going to be now a reset, and there's a new age of AI coming. So, you know, watch out for this space. That's all I'm going to say.
Yeah, exactly. And I think, you know, again, kind of speaking to what we talked about before, you know, we had like some of the first AI ever was in MATLAB, right? And like now that it's becoming so so much more accessible to regular humans, to computer scientists, you know, the hardware is available, you know, more people are just every day, you know, contributing and everything. And I think there is, like Yann said, there's this sort of perception that, you know, MATLAB is very slow. And that's because we have this 6-month, you know, cycle where, like, again, we can't just like throw that model like on landing your plane. Like, sorry, like we don't want you to die. We're gonna test it out first. And like, we're gonna make sure it's okay. You know, you can use the GitHub models, that's fine. But you know, that sort of 6-month cycle is sort of what we're famous for. And, you know, that's the reason, because, you know, people aren't just gonna take what was submitted last night and land their plane with it, you know? So I think there's a big balance that, you know, we're working with so many active contributing members of the AI community, and then those trying to implement it into their engineering projects. So yeah, it can lead to some misperceptions.
Excellent. Guys, first of all, thank you so much. It was kind of a fanboy moment for me. Yann was always someone I was looking up to when I first met him on LinkedIn. Heather, also, you're like kind of a famous person in the MathWorks community. So
MATLAB famous.
So pretty cool. And of course, if the people want, we can also talk about deep learning or reinforcement learning with someone else on the podcast. It would be super interesting. And make sure you follow Heather and Yann on social media. We'll also share these links in the description. Any last words from you guys to maybe close the podcast session?
Oh, thank you. This is a great conversation. I love that we're all sort of like MATLAB and Python fans, so we can kind of talk about this, like, you know, not versus. It's all about the love.
Let's go. Yann, any last words from you?
Well, thank you for having us, Jousef. I was really looking forward to that, and I think it went out pretty well. So I'm looking forward to, you know, next conversations.
Perfect. Guys, let us know in the comments how you like the podcast, and thank you, guys.
Yeah, thank you.